Hello everyone, welcome to Class Connect study series with Yusuf Arikewuyo. Today we shall be considering scalars and vector quantities. Scalar quantities are quantities that have attribute of magnitude that is size alone without direction. Vector quantities are quantities that have attribute of both magnitude, that is size, as well as direction. Let's consider some examples of scalar and vector quantities. Some scalar quantities include speed, distance, energy, mass, area. A measurement written as 5 meters without any corresponding direction is a scalar quantity or a scalar measurement. 5 joules corresponding to energy is a scalar measurement. Some vector quantities include displacement, velocity, weight, acceleration, momentum. For example, if we write 5 meters, for it to be a displacement, we must write 5 meters, maybe due east, with corresponding direction. 5 meters due east is very different from 5 meters due north, because the direction in both cases are not the same, though the magnitude are the same. Calculations involving scalars and vectors. All mathematical operations can be performed on scalar quantities. For example, the addition of 8 meters to 5 meters gives 13 meters without any consideration given to direction. This is so because we just added two distances to each other. For the addition of vectors, we do what is called resolution of vectors, because there is always an angle of inclination between one vector and another. Then for us to add the two vectors together, we must resolve the vector considering the angle theta between them. Suppose there exist two vectors A and B inclined at an angle theta to each other, then the following holds. In general, the resultant vector r can be computed using r squared equals a squared plus b squared plus or minus 2ab cos theta. From the formula, we can deduce three cases. These are: case 1, when the angle of inclination theta is less than 90 degrees. The formula becomes r squared equals a squared plus b squared plus 2ab cos theta. Notice that the plus or minus in front of 2ab cos theta for theta less than 90 degrees takes the form of plus 2ab cos theta. The second case is when theta, that is the angle of inclination, is 90 degrees. Then the formula becomes r squared equals a squared plus b squared. This is so because cos theta, that is cos 90 degrees, equals 0. And of course 2ab times 0 will give 0. So we are left with r squared equals a squared plus b squared. The third case is when the angle of inclination theta is greater than 90 degrees. Then the formula becomes r squared equals a squared plus b squared minus 2ab cos theta. Notice that the plus now is minus. This is so because theta is now greater than 90 degrees and we are approaching the second quadrant, or we are already working in the second quadrant, and of course in the second quadrant sin theta is the only one positive while others tan and cos are negative. Let's consider this question. Two forces of magnitude 3 Newton and 5 Newton are acting at an angle of 45 degrees to each other. Determine the magnitude of their resultant. We shall start by identifying given parameters. In the question, we are given two forces. Let's denote the first force F1 as 3 Newton, the second force F2 as 5 Newton. The angle of inclination theta was given as 45 degrees, and in this case theta is less than 90 degrees. So that our formula for the resultant force R will be given as, this one should be r squared, will be given as f1 square plus f2 square. This time around, since theta is less than 90, we'll stick with the plus 2f1 f2 cos theta. So that if we substitute values, we shall have 3 square plus 5 square plus 2 open bracket 3 multiplied by 5 cos 45, and this will give us 9 plus 25 plus 2 multiplied by 15. Cos 45 is 0.707, which of course will give us 34 plus 30 multiplied by 0.707. Let's take the next slide. We shall have r squared equals 34 plus 21.21, which of course will give us 55.21. If we take the square root of both sides, we have that r equals the square root of 55.21, and therefore the resultant force r is obtained as 7.43 Newton. Therefore, the resultant of the two forces inclined at 45 degrees to each other is obtained as 7.43 Newton. Thanks so much for watching. Hope to see you in our next class, and please do not forget to subscribe and click on the notification button. Thank you.